Greetings, Patriots. Today's lesson will be on writing and solving inequalities with variables on both sides. Don't forget to use your vocabulary resource that you have been provided to help you select the appropriate inequality symbol. Make sure you set yourself up. We will practice a few I do and we do problems prior to your assignment. So today's objective is you will write inequalities with variables on both sides, given a situation, and you will also practice matching an inequality to that given situation. Here is that symbol vocabulary resource. Please make sure you have this available so that you can review it and have it handy as you work on these problems. Okay, so let's go ahead and take a look at first this problem. If you pay a one-time fee of $24, you can buy tickets for a music concert at a reduced rate of $17 per ticket. Okay, so that's if you pay that one-time fee. That's for our reduced tickets. Regular tickets are just costing $25 per ticket. So our job is to write an inequality that can be used to determine the number of reduced price concert tickets that you would need to purchase in order for that total cost to be less expensive than the same number of regular tickets. So we know that that less expensive goes with our less than symbol. And let's go look at the expression for reduced price tickets. Well, the only way I can get a reduced price ticket is if I pay $24 up front and $17 per ticket. So I'm looking at those concert tickets, okay? And regular tickets I know cost me $25 per ticket, no one-time fee. So I want to know when the price will be less expensive in regards to the number of tickets that I buy for reduced price tickets versus regular price. So as I look at my following inequalities, well, I know that if I look at A, they're multiplying that per ticket, and I know that that's wrong for my reduced tickets because my reduced price tickets are $17 per ticket, so A cannot be an option. If I look over here, it's 24 plus 17x is less than 25x, so therefore B would be the best choice that represents this situation. So let's take that inequality and let's work on solving it. We've been working with solving equations and nothing has changed. We know that the process is going to be the exact same. So we always want to start off with making sure that we move our variable to one side of our inequality. And so I'm going to go ahead and move that 17x by doing the inverse of that and that forming zero pair. But once again, what I do to one side, I must do to the other side. So when I subtract 25 minus 17, that leaves me with 8x and 24 on the opposite side. So in order to solve for the number of tickets I'm going to need, I'm going to divide by that coefficient of 8, and what I do to one side, I do to the other. So this is looking for the tickets that I would have to buy, right? So I'm left with my tickets, and here it says that my tickets should be greater than 24 divided by 8, which is 3. So what this is actually saying is I need to purchase more than, remember we can read our inequality from left to right or right to left. So this says 3 is less than the number of tickets, but I'm reading it from the variable. So how many tickets do I need to buy for it to be less than? I'm going to need to buy more, right? I will purchase I will have to purchase more than 3 reduced concert tickets, reduced price tickets. That's what this says. In order for the total cost to be less expensive, okay? So I always like to check that, okay? Because if I take, so what are numbers that are more than 3, right? So if I think about that in my solution set, well, if I buy 4 tickets, if I buy 5 tickets, etc., right? That's going to be when the cost will be less than, right? Less expensive. So let's test our solution, okay? If I buy reduced tickets, which is right here, and I'm gonna use, this expression right here. Here's my reduced tickets, 24 plus 17 times, what did I get for my solution? More than 3. So I'm going to try 4. Okay? So when I go ahead and substitute that, I'm going to see if it's going to cost less than the regular price tickets at 25 times the 4 tickets. So if I multiply 17 times 4 using my decimal calculator and I add the 24 to it, that gives me $92 with the reduced price. And that's less expensive than $100. So this lets me know, and I like to check, I can still check, I have to buy more than 3 at the reduced price in order for my cost to be less expensive than the same number of regular tickets. Okay, let's go ahead and do another problem. Trash management charges its customers a fee of $24 plus $8 for each trash can that they empty. Waste Away is charging its customers just $12 per trash can that they empty with no additional fee. So we need to write an inequality that can be used to determine the number of trash cans. Okay, so I'm looking at those number of trash cans for which it's going to be more expensive for a customer to use Waste Away as their trash service. At what point will it be more expensive? Well, let's go look at Waste Away. Since I'm comparing Waste Away here, that's $12 per trash can. So I know my trash cans is my X, so $12 per trash can. I'm multiplying by that. Trash management, on the other hand, is charging a $24 upfront fee plus $8 for every single trash can that they empty. So those are my 2 expressions here. Okay? And I know I'm looking to see, based on the number of trash cans that I get, where Waste Away is going to be more expensive, right? After so many trash cans. Okay? So let's go ahead and look at which inequality is the best fit here. All right, so I know that this expression for trash management is correct, and 12x is also correct. So now what I need to make for Waste Away is also correct. So I need to make sure that 12x is greater, which it is in this case, is greater than trash management. Okay, so that's looking good. Let's go ahead and check out this expression. Well, this says it's at trash management, it's 24 plus 12x. Well, I know that's incorrect because trash management is charging those $8. So this expression is incorrect. It's really important that you take the time to read your inequality. This is why I always recommend write the expressions first before you choose the correct inequality. In some cases, you're not going to have to solve. You're just going to have to choose the correct match that goes with the scenario. So you need to be comfortable writing them. So I'm going to take this inequality. I'm going to solve it. So it was 24 plus 8x, right? And we were looking at when trash management, and this is, waste management, Waste Away should be greater than or more expensive than trash management. So my job is to figure out after how many trash cans will that actually occur. So remember, we're looking for the number of trash cans when Waste Away will be more expensive. So yes, this is more expensive. Okay, let's solve this normally like we do equations. Remember, I want to move all my variables to one side. So I'm going to go ahead and start off by doing that. Move my variables over. That's going to leave me with 24. 12 take away 8 is the coefficients. I'm subtracting that, and I'm left with 4x. Well, I'm going to divide by 4 on both sides, and I'm going to bring my inequality straight down. That means that my trash cans, right, the trash cans have to be greater than 6. I have to empty more than 6 if waste away is going to be more expensive, right, to the customer. So this says, right, it will be more expensive. I'm just writing a sentence so that you understand. It'll be more expensive at waste away if you empty, sorry that it's hard to write, more than 6 trash cans. So let's think about possible solutions. Okay, more than 6 trash cans. That's what I'm trying to write, guys. Okay, so what are some values that would make this inequality true? Well, what's more than 6? 7 is more than 6, 8 trash cans, 9 trash cans, 10 trash cans, etc. And this would go on. So there's several solutions, right, that make this inequality true. So let's check it. Let's see if this would actually work, okay? So let's say I chose 6. All right, I like to do that as well. So I'm comparing trash management and I'm comparing waste away. Let's just pretend that I chose 6, okay? And I need this to be greater than, right? More expensive. So I'm going to go ahead and just take the expression 24 plus 8 times 6, right? And waste away would have been 12 times 6. So when I type this into my Desmos calculator, that gives me $72, and 12 times 6 is also $72. So this would not make this inequality true. This would be not true because at 6 trash cans, both establishments cost the exact same thing. I want to know after how many trash cans is waste away going to be more expensive. So let's test our solution of 7 trash cans because it said more than. So this is another way that you can eliminate, right? And make sure that your solutions that you're representing are true. So let's try 7 and 12 times 7 on this side for waste away. So when I enter 24 plus 8 times 7, I'm going to get 80 on my Desmos calculator, and 12 times 7 I know is 84. So there you go. More than 6 trash cans, right, will ensure that waste away is going to be more expensive because 84 is greater than 80. That's when it'll be more expensive, okay? When we have more than 6 trash cans being emptied. All right, now it's turn. You are to read this, attempt this first by yourself, and then check your answers. That's the only way we know that we're getting better. All right, welcome back. Ian wants to promote his band on the internet. Site A offers website hosting for $4.95 per month with a $49.95 startup fee. Site B is offering this website hosting for $9.95 per month and no startup fee. So we need to see after how many months would Ian need to keep the website for Site B in order for it to be less expensive than Site A. So he's trying to save his money. Well, let's see what we know about Site A. We know they're having that $49.95 startup fee and that $4.95 per month. So I know X is my months. I'm looking for that. For $4.95 per month plus that $49.95, right? Startup fee. Site B is going to cost $9.95 per month. Okay, so I want to know when Site B is going to be less expensive. So therefore, Site B needs to be less, right, than Site A. So let me see how this would look. I'm checking site A here, $49.95 X plus 4. Oh, this is wrong because the months are not being charged at $49.95. So that expression is already making this wrong. $9.95. This is site B. We want site B to be less expensive, so that's correct, than site A. All right, we'll have to solve that one. So that's it. So we have $9.95 X less than $4.95 times the number of months plus the $49.95. Okay, so once again, I need all my variables on one side, so I'm going to move the $4.95 X. What I do to one side, I do to the other. And when I subtract that, that gives me 5x. You guys have a calculator. You can use that in order to check your answers. This forms 0 pairs, and this is what I'm left with. So my final step is to simply take and divide by the coefficient of 5, right, in order to figure out the number of months. So when I do this, I see that when I take on my Desmos calculator $49.95 and divide it by 5, I get 9.99, right? So the bottom line is my months really need to be, right, between 0 to 9 months, because months have to be less than this value, and this is almost 10 months, right? So let's check, right? If I check this, let me check anything less than 9.99. Well, 9 months is less than 9.99. 8 months is less than that. 7 months is less than that. 6 months is less than that, and so forth, right? So if I type, let me go ahead and check my solution. Let's just try 9. Let's see if that will make this true. Where at 9 months, will site B be less expensive than site A? All right, so with my calculator, I can take $9.95 and multiply it by 9 months to see if that's going to be less than the host site A at $4.95 times the 9 months plus that $49.95. So we would have to check that. Well, when I multiply $9.95 times 9, that brings it to $89.55. Okay? And so now I'm typing $4.95 times 9 plus $49.95, and that's going to give me $94.50. So this is true. So any months that are less than 9.99 or less than 10 pretty much months will make this inequality true. Okay? All right, now you try. Okay, once again, and then check your answers. It takes Lucy 20 minutes to bike to the pool and this should actually say 3.5 minutes. I'm not quite sure. Look at your guided notes, but it's 3.5 minutes per lap to swim the pool. Dan takes 30 minutes to jog to the pool and 2.75 minutes per lap to swim in the pool. So they want to know after how many laps. Okay, so therefore there's my x, right? My variable. Must Lucy swim in order for her to spend the same number or more minutes exercising than Dan? So let's look at Lucy. We know it takes her 20 minutes to get there on the bike plus 3.5. And I'm just going to convert my 1/2 to 0.5. 3.5 minutes per lap. Dan, it takes Dan 30 minutes to jog to the pool plus 2.75, which is 2.75 times the number of laps in order to get a lap done. Okay, so I want to know when it's going to take Lucy more minutes, more or the same or more, greater than or equal to, right, spend the same or more minutes exercising than Dan. So that's going to be determined by her laps. All right, so let's go ahead and look at these two. I don't know why my inequalities aren't coming out, but this was the first one. I apologize for that. And this is the second one. So I can see here that they are comparing Dan right here and Lucy. So let me just check their expressions. Dan should be 30 plus 2.75x, right? And 20 plus 3.5. Okay, so their expressions are correct, but here it says that we're looking to see when Dan is greater than equal to. So I'm not sure I'm agreeing to that, because this one said we're going to compare when Lucy is greater than or equal to. And this is Lucy and this is Dan. So let's see this one. Are my expressions correct? Yes, here is Dan. And here is, let me see, Lucy. So they're both correct, and Dan has to be less than, right? So this one has to be correct because Lucy has to be greater than or equal to Dan. So now our answers. Okay, so here's our setup. Let's go ahead and start by, again, moving all our variables over to one side. So I'm going to move the 275x over. This gives me 0 pairs, and that end up with 30 and 20, right, plus 75.75x. All right, so now we're going to go ahead and move our 20, that forms 0 pairs. I need to move all my values over to the left side, and that leaves me with the following. So when I divide by 0.75 on both sides, okay, I end up with x has to be greater or equal to 13 1/3, right? 13 1/3 laps. So we're solving for the laps. So she has to swim according to this, right? She has to swim. How many laps must she swim in order for her to spend the same number or more minutes exercising than Dan? She must swim, and I'm going to put Lucy must swim 13 1/3 or more laps in order for her to, right, spend the same number or more minutes exercising than Dan. All right. It's also important that you always put this in context, okay, guys? So you will have an opportunity to work on a situation where you're writing the equality and solving and getting your practice in. All right, Patriots, have a great day.